We have seen the conversion of temperatures, right? And temperature scales we have done. Kelvin to Celsius, Celsius to Kelvin. Good evening, Dhanishri. Okay. And then we have studied about the different, different phases of matter. Or you can say conversion of matter we have done, right? Okay. So, can anyone tell me how many types of conversions are there? Terms. What are the different processes under which a particular matter goes through to show different phases? We have learned how many? Anyone? Six conversion of matter, Mehak. Okay. Can anybody enlist them? What were they?
Evening, ma'am. Can I, ma'am?
Yeah, please, Mehak. You can.
Ma'am, solid to liquid is melting, and liquid to gas is boiling or evaporation, and
Mm,
gas to solid is deposition. Uh, then liquid to solid is freezing.
okay.
Then gas to liquid is condensation. Solid
Hmm.
to gas is sublimation.
Very good. Thank you. Thank you, Mehak. Only one thing is there. For the melting, you can use the fusion. Okay, because we have learned this term. Then fusion is good when we convert solid to a liquid. Okay. And then liquid to gas, we have learned evaporation. Also, boiling is correct. Then we have done gas to liquid, that is condensation. And then we have done liquid to solid, that is, oh, wait, this we have done. Had we done liquid to solid, students? Like apart from these term, have we done solidification, students? Have we learned this term? Just let me know, because I think there was not mentioned solidification. Anyway, I can mention it. No? Okay. Okay, so liquid to solid is solidification. It's like when you turn liquid into ice. Okay. You can mention this one also. Otherwise, we will open up the diagram and we will see how many we have done. And then there is one deposition, which was gas to solid, is left. And then solid to gas, which is sublimation. Still, there are six only. Okay, we will see. Now, I just want to know, when we convert the solid to a liquid, do we provide heating? Do the temperature is provided? External temperature is provided? Do we need temperature to convert solid to liquid, students? Anyone? Temperature is required or heat is required or not when we convert this solid to heat? Required? Heating is required? It means we are increasing the temperature. Now, when we convert liquid to gas, we also need here temperature. That means we are providing heat to the gas. Now, when we convert the gas to liquid, do we need heating or what do we need? Which factor is responsible to convert gas to liquid, students? Anyone? Do we heat the gas to convert liquid or we will cool it? Which factor is responsible for changing gas to liquid? Deposition is the process. Which factor is responsible to convert the gas to liquid? No one? Okay, so that is cooling, no? Opposite of heating. And then liquid here, liquid to solid. Here also we need cooling. Now, as in the previous class, I have told you there are two major factors which are responsible to convert a matter into certain other phases of matter. What are they? Two major factors which are responsible. Nobody remembers? Are you all getting my question? No. What I am asking, two factors which are responsible to convert the one state of matter to different state of matter. So that was temperature and pressure. From here we started, no, temperature. We have started learning the topic in the previous class. We have started from here only. The factor which is responsible to convert one state to other, that is temperature. We have learnt about temperature, that when we keep on giving the temperature, we can convert the solid to liquid, liquid to gas. But what about cooling? What do we do in cooling? Does the temperature is also increased? Or there is some support of pressure as well here when we convert the matter like gas into liquid? Pressure is involved. So yes, pressure is involved. The second factor when we which is required to convert one state of matter to other state of matter, we require pressure. Now one thing that is to be noted, the temperature is always increased when we are converting these one state to the other, but pressure always go opposite to the temperature. Remember that, because certain times many question will ask, like ask you to answer that if solid is being converted into liquid and we are providing high temperature to this, what will be the role of pressure here? Will pressure also increases? Will it increase, student? When we want to convert the liquid into solid, will we apply the temperature or we increase the temperature in this case? When we want to convert liquid to solid? You all are there, no? You can write down in the chat box if you don't want to open up your mic and say. We are learning about the second factor which is responsible to convert different states of matter apart from temperature, and that is pressure. Pressure always go opposite to temperature. So we will provide pressure when we convert liquid to solid, and that pressure would be decreased or low because temperature is high. So whenever that is the case, when we are providing high temperature to certain matter to convert into other matter, we are providing high temperature to that particular matter. In that situation, we need low pressure, students. Okay. So temperature is inversely proportional to pressure. Remember that. When temperature is increased, pressure is decreased. Pressure is decreased, temperature is increased. This is the point that is to be noted in this chapter, which is important regarding the conversions of the states. So all this is clear. Anybody, if anybody is writing it down, because I think this diagram is also important. With the diagram we have learned in the previous class, which was about the different processes which help us to convert different states of matter. Anybody, any doubt till here? Because related to this part, there are questions. Why very little, like very less people join today? Okay, at least say done or we should proceed further in the chat box if you have any doubt. Okay, Pranit, thank you for the confirmation. Now I'm going to erase this up and then we are going to study the next part. Also, we have done evaporation also, right? Okay, let me erase this up. All right, so this was the diagram we have done in the previous class where I have also cancelled this one up, which was gas to solid, that was deposition. Okay, this we have done. Everybody can, who was not there, just correct it up. Mhm. Why it is not erasing now? Uh, okay, now we are done. All right. So effects of change of temperature, we have done the solid to liquid is known as melting. So what is the melting point of solid, students? Anyone? What is the melting point of solid? The process
It
in which,
varies.
tell me.
It varies.
It varies. Okay, what is the like exit amount? Like we study about the melting point of a solid or an ice. Okay, now you can say melting point of an ice.
0 degrees Celsius.
Okay. So we have done heat of fusion, like fusion we have studied in the previous class, students. Latent heat of fusion we have studied. Had I given you the definition for latent heat of fusion? Okay, no. Okay, so fusion, we already know that when we convert the solid to liquid, that is fusion. So the temperature at which a solid substance melts and changes into liquid at atmospheric pressure is called the melting point of a substance. Melting point is correct, like 0 degrees Celsius. The melting point of a solid is a measure of the force of attraction between its particles, atoms, or molecules. Now there is one thing we have to learn more in this fusion. Let us see it is there or not. Yeah, it's not there. Okay, so we are going to study about the latent heat of fusion. This is also important. Now, what happened now, students? The heat which is required to melt up this ice, okay? The minimum heat which is being required to melt it down and to convert it into water, or you can say the liquid solid into water. When 1 kilogram of a solid is being changed into water by when you provide it temperature at its, you can say at its melting point. This is known as latent heat of fusion. What happens? No, whenever we will try to measure this water, it will remain with the same mass, 1 kg or 1 liter, you can say. Plus, the temperature also remain constant. At the same temperature, we are melting this solid into water. That is known as latent heat of fusion. Temperature will not vary here, even the mass. That is known as latent heat of fusion. Students, are you able to get my point or no? At a constant temperature, when a 1 kg of solid is being turned into liquid, that is known as latent heat of fusion. The minimum heat which is provided, not provided, but yes, the temperature will not change at its melting point. That is known as latent heat of fusion. Anybody, any doubt? Because this is important, students. Temperature will remain constant and 1 kg of solid will turn into water. Okay, I'm going to write the definition of latent heat of fusion. I want you all to write it down as well. Okay, so heat needed to convert 1 kg of solid to liquid at melting point. Now there is a question which they can ask you. We got it that solid is being converted into water. Heat is also there. We are not providing it externally, but heat is still here. That is why solid is being converted into water. But what had happened? Like, where does that heat gone? What does that heat is doing to 1 kg of solid? Anyone? Like, they will ask you the question, when a solid melts its temperature. Okay, I'll ask. This is a very common question. You can find it in your textbook even. When a solid melts. Okay, so I got a answer, I think, in the chat box. Between the particles. Okay, so between the particles, what does this heat is doing there? Can you tell me the function of this heat? When a solid melts, its temperature remains the same. So where does the heat energy go? So this is the type of question that you might see in your textbook. First of all, you just need to mention the heat which is provided is known as latent heat of fusion. So this question demands that you need to mention latent heat of fusion anywhere in the answer. Okay. Plus, Ohm's replied that it is between the particles. So what does it doing in the between the residing between the particles? It is required to overcome the bonds present between the solid particles, to break them up and to convert the solid into water. In this way, you have to write the answer. Shall I write it for you, students? If you want me to write the answer or frame the answer, I will write it for you. Latent heat of fusion. So latent is like the minimum heat. Okay. Yes, about what? Do you want me to write it, Om? Is that yes for writing? Okay. Okay, Pranit. Okay. So I'm writing it here or here. Where should I write? Why very less students joined today? Is the class boring? Or the chapter is boring? The heat which is provided is called latent heat of fusion. Now the rest of the part I'm writing this side on the top. The heat or the hidden heat, you can write heat gets used up in changing the state by overcoming the forces of attraction between the particles. So this is how you need to frame this answer for this type of question. Or sometimes they can ask you, what is that hidden heat? So you can mention that that hidden heat is a latent heat of fusion in this way. Let me know when you finished. Done. Okay. Let If anybody else is writing, just let me know. Done. Okay. All right. Next we will do boiling. Now what is boiling? Is boiling okay, tell me what is boiling first. Why it is not erasing? Anyone? Okay, so what is a boiling point of liquid? Is boiling a bulk phenomena, students? What do we do in boiling? Why it is not erasing? Anybody, what is boiling? Till then you can answer me the question. Yes, it's a bulk phenomena. Okay, thank you. Okay, so it is not going fully. So boiling is when we convert the liquid and like we provide external temperature to the liquid. Yes, correct. Oh, conversion of liquid to gas at boiling point is 100 degrees Celsius. Okay. So we can do like we can convert the liquid into vapors by two processes. One is boiling and one is evaporation. Now, there is like they can ask you the major question can come is what is the difference between boiling and evaporation? So first thing first, the process in which a liquid substance change into gas rapidly on heating is called boiling. This we already know. The temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure is called boiling point of the liquid, which you know that is 100 degrees Celsius. Boiling point of water is 100 degrees Celsius. Boiling point of alcohol is 78 degrees Celsius. Now, before this one, we have two things to cover, which is not here. First is latent heat of vaporization. Anybody know about it? Very important from this chapter, latent heat of fusion and latent heat of vaporization. Since we have already studied latent heat of fusion, now I think you students can also answer about latent heat of vaporization. Anybody? Latent heat of vaporization. Same thing. The heat which is involved to convert the liquid into vapors, but you need to mention here at boiling point. Okay. So same thing is done here when we are taking the liquid and we are changing it into vapors, but the temperature remain constant. That is known as latent heat of vaporization. I'm writing it here, latent heat of vaporization. So here the spelling is little mistake. Okay, vaporization. Now who can tell me three differences about boiling and evaporation? There are how many students? There are three, four, seven, six students are there. So one, like everybody, one difference from each student. So boiling is a bulk phenomena. We got that right, right? But like in evaporation, the heat is involved? Is the heat
And the
involved?
evaporation is a surface phenomena, ma'am.
Okay, thank you. Thank you, Mehak. Okay. So in evaporation, we do apply external temperature. Anyone? Any external temperature is provided or it will like turn into vapors on its own? Does that happen? Yes. We do not need any external temperature in evaporation, but the condition is that in evaporation, only that liquid which is below, like which is below 100 degrees Celsius, they can like change into vapors without any external temperature. Okay. This is a major difference. Okay, one thing I have to make you write about evaporation. Wait. The differences are important. Huh. So you can make a table, students. Should I write it? We are going to write some differences between evaporation and boiling. This question is important. Huh. Okay, so evaporation. And the next one is boiling. So first, evaporation, it can takes place at all temperatures. Like we do not need any external temperature to heat that up and to change it up. It takes place only at fixed temperature, and that is boiling point. Number second, this is a slow and gradual process. And it is a rapid and violent process. It takes place, like Mehak said, it takes place at the surface. of the liquid, and number third, it takes place over the entire liquid. Now, fourth one is a turning point. So in the boiling, no, we are increasing the temperature. Of course, the water get heated up, and it's like there will be the feeling of heat in the environment of the boiling, where we are going to boil up the liquid. But that does happen, but it happens in evaporation also. Is there the heating feeling, like heat feeling around the certain matter which is being evaporated? Is that so? Boiling gives us heating. Does evaporation also gives us heating?
No, ma'am.
Correct. So what does it give? Opposite of heating, that is cooling. So we can write down number fourth. Here I'm going to write down about the boiling. You can write down it does not provide cooling effect. And in the fourth point of evaporation, I'm writing it here. It provides cooling effect. Now, in this cooling effect, you will get many questions to, like, they will ask you in the from this part, cooling effect of evaporation. First, you will finish this one and let me know in the chat box. Very important question. And evaporation definition also you can write down here. And students, hope you have written the definition for latent heat of vaporization. Do you want me to write that as well? Just let me know in the comment box, like in the chat box. Latent heat of vaporization, everybody? Hmm. So first you can write about the evaporation here. Only writing that it turns liquid into vapors is not enough. You need to write down the whole definition. And the definition is the process or phenomena of change of liquid into vapors at any temperature below its boiling point. So it's called evaporation. And for latent heat of vaporization also I'm writing. I'm writing it here. So for latent heat of vaporization, you can some of the textbooks may have like Z here and not S. So since everybody is writing Z, so Z can be taken as the correct spelling as well. So heat needed to convert. Where's my pen? This is the latent heat of vaporization. Both the definition is important. This differences is important. Now this is the easiest chapter, but you will like you can see many questions like reasons based question can come from this chapter. Also, you need to be precise in writing the definitions. They will like find the mistakes and will cut from this chapter. It is easy, but in checking it makes difficult when you are not substituting certain important terms from the definition. So it is important to write down the important terms. When you like finish, just let me know in the box. What else is left? Okay, we have done this one. So after this, we are going to start with factors affecting evaporation. So there are certain factors which are responsible to for the evaporation to get it like frequently, gradually, faster. For that one, we have certain factors which are responsible. We will see them as well. Just let me know when you have finished, students. Done, everyone?
Yes, ma'am.
Okay, thank you. So I'm erasing this up. Anybody else want to say like one student also confirm? At least one more student. So I hope you have done. Okay. Okay, got it. So everybody. Hmm. Okay, so factors affecting evaporation. Do you know any factors which is responsible to increase the evaporation or decrease the evaporation?
Ma'am, for increasing evaporation, the
Hmm.
factors are temperature, humidity, and surface area,
Okay, great, great, great.
and wind speed also.
Which one? At the end?
Wind speed.
Wind speed. So these are certain factors, correct? So temperature is the first one. So as the temperature increases, evaporation also increases. That means it is directly proportional. Okay. Now the next one is surface area. So surface area increases, evaporation also increases. And the next one is humidity. Humidity is like inversely proportional. When there is humidity, like maximum number of water vapors are there in the environment, so evaporation lessen up or decreased. Okay, remember that. So in the places which are near to the beaches, they have very high amount of humidity and lesser evaporation. So that is why always they feel like watery, like moisture is there in the environment. Okay, so it is inversely proportional to evaporation. Now the last one is wind speed. Wind speed is directly proportional to evaporation. Now they are not going to ask you direct question. Okay, they will make up a question, like they will make up a situation, and then they will ask you the factors which are responsible for evaporation. So, but in the same thing, you have to like remember these factors which are responsible, and you can frame the answer. Okay, in this way only. All right, now this we have completed. Now we are going to start the next thing. Like, can I erase this up?
Yes, ma'am.
Okay. Anybody else? Okay. This we have covered. Now the next one is condensation or freezing. Gas to liquid. The process of changing a gas to a liquid by cooling is called condensation. There is nothing much like to learn about condensation. Yes. Mhm. Okay, so is condensation involved in the water cycle, students? If it is involved, then to which part that does the condensation happens in water cycle? Anybody? Yes, yes. So in which part? In which part, students? The condensation is happen in the water cycle
Ma'am,
when
when
vapor.
evaporation happens
Hmm.
and vapors cool down and form cloud.
Okay. So vapors like gases turn into liquid and that liquid condense up and then they form the clouds. That is known as condensation. Okay. Correct. So for this one, you can write down the definition if you don't have. Otherwise, it's fine. Next one. Condensation is a reverse of boiling. Can we say, are we all agree with this point that condensation is a reverse of boiling?
Yes, ma'am.
Okay, so if we are providing, like if we increasing the temperature and we are boiling up the liquid, so when we have to convert that liquid into the this one, we have to like condense that liquid. What we will provide, like in the terms of pressure or the cooling effect, does the pressure will increase or decrease at that point of time when we are reversing the boiling? Anyone? Any guesses? Does the pressure increase or decrease? Now only I told you now that temperature is inversely proportional to pressure. So we want to reverse the boiling now. So what we will do in terms of pressure I want? Anyone? We will decrease the pressure, no? Because in the boiling we are increasing it. So we will decrease it up to reverse the boiling. Okay, we need to write that up also about the pressure. Okay, so this is all about the water cycle only. Plus, do you know about the transpiration since it is here in this picture, and also the precipitation? You know about precipitation, transpiration? Anybody? Any doubt? Anybody? What is transpiration, students? Tina, you want to
Ma'am,
say?
I know about precipitation. Ma'am,
Huh?
I know about precipitation.
Okay, tell me about precipitation then.
Ma'am, I know about ma'am when water vapors
Hmm.
come uh, come on the land in the form of rain
Okay. Okay.
or
Okay.
snow.
So precipitation, thank you, Tina. So precipitation are the forms of rains. Okay. what happened? No, in the northern plains, we get the rain in the form of liquid, right? But as we go up in the hills where there is a like polar region is there, temperature is low. Okay, temperature is low, then the liquid which like tends to fall in the form of rain, or the rain which is falling in the form of liquid, changes because temperature is low, pressure is high, and that liquid turn into snowfall or hailstones. So these forms of rain, like the hailstones and the snowfall, all these are considered as precipitation. Precipitation means the solidification of liquid actually. Got it? So this all this hailstorms and snow happens when there is like the hilly region is there, or the polar region is there. Sometimes northern plains also get this hailstorms. Hailstorms in Hindi we call it ole, right? The balls of ice which comes. They all are the rains, but it depends upon the temperature and pressure. Okay, it changes their form. Okay, you got it? Precipitation are the forms of rains only. Now, transpiration. Transpiration is very like interesting process which happens inside the leaves, okay, inside the plants, or is shown up by the plants. Now, when we keep on giving water to the plants, no, there must be an excess water which the plants can't store, or they are filled with water and they do not want any more of water. So transpiration is that water which comes out, the loss of water in the plants in the form of droplets on the leaves. So in a simple words, we can say it's evaporation only, or you can say it's a sweat which is coming out of the bodies of the plants, right? It's a byproduct which is not required by the plants. Okay. So transpiration is that process in which the water keep on exiting out the excess water. All right. So all this is a process which is, transpiration. There is one importance of transpiration. Can anybody tell me what is the importance of transpiration for our ecosystem? As we know now that transpiration is equal to evaporation only. So what does transpiration is doing in this water cycle? Anybody? You can think of it. See, in the whole water cycle, evaporation plays a very, very important role. Because if evaporation is not there, then how come water is going to change into vapors, right? Transpiration is also the same thing. Leaves are helping the ecosystem or the environment so that they can also get the vapors which are coming out of the leaves. And then they will gradually convert into rain. That is why it is said to grow more and more trees so that they will more transpire. And when they will transpire, there will be rain. That is why in the temperate evergreen or the forest, Amazon basin, all these have million of trees there. So they used to face ample amount of rainfall because of this transpiration coming from the plants. Got it? So transpiration is basically is equal to the evaporation only, which is keep on giving the vapors to the environment. Remember that. Okay, so in this process, water vapor formed due to evaporation rises up, the temperature is low, so vapor condenses to liquid and form clouds. This we have already discussed. Anybody, any doubts in this one? Condensation, which is taking place in water cycle. I hope you won't have any doubt in this one because we are keep on learning these things from the primary section only. Now, now there is liquid to solid, which is known as freezing. So solid to liquid fusion and liquid to solid freezing. Remember that. So process of changing a liquid into a solid by cooling is called freezing. Very easy. Okay. Water. And then we have ice. We have converted through the process of freezing. Freezing is the reverse of melting. Okay. Now again, latent heat of fusion and latent heat of vaporization is here, which you already know. Now we will understand, okay, what does the slide says? Which basically we have done. Okay, we are going to see this with an example. Okay, wait a minute, students. It's not going up. Hmm. Okay. All right. So we have taken some crushed ice in a beaker. Okay. Now what we are going to do with this ice? Suspend a thermometer in it. We are going to hang the thermometer in this beaker. Note the temperature of ice. Okay. We are noting down the temperature of this ice. 0 degrees Celsius because it's a freezing point. Now the heat, now we are going to provide the heat that is going to turn the ice gently by using a small flame of the burner. We are going to provide the heat. As long as there remains even a little of ice in the beaker, there is no rise in temperature during the melting of ice. Okay, remember that this is what is happening in latent heat of fusion. We are converting the solid to liquid by like at a constant temperature. Okay, temperature is not changed, which we have studied in the definition earlier. So the heat which is going into ice but not increasing the temperature is the energy required to change the state of ice from solid to liquid, and this is known as latent heat of fusion of ice. This we have already studied in the definition before, but now we have done with an experiment to show that the temperature remain constant. Anybody any doubt in this one? This is a proof
No,
to our
ma'am.
definition. Okay, Tina. Okay.
Ma'am,
This
my
latent.
name is Lavanya.
Okay, Lavanya. But your name shows here Tina. So, okay. This latent heat of fusion or melting of a solid is the quantity of heat in joules. Okay. So, whenever we are calculating the energy, we always calculate the energy in joules. So, joules is the SI unit of heat energy or energy required to convert 1 kilogram of the solid at its melting point to liquid without any change in temperature. So it's nothing when you are converting the solid to liquid, same as you're doing in fusion, but here temperature will remain same. Temperature will not differ. And also you have to write it down at its melting point as well. Okay. The latent heat of fusion of ice is 3.34 times 10 to the power 5 joules per kilogram. Now this one you can write it as we have done in the melting point, boiling point. Now you can mention this point as well. What is the heat of fusion of ice? You can mention this as well. Done, no? I have changed the slide. Okay. So this heat energy is used up in the changing the state of solid substance by overcoming the force of attraction between the particles. We have done as this one as the question. Where does the heat go on, or where what is the hidden heat? All this type of questions they can ask you, and now you got the answer as well. Okay. Now there is okay, one question is there. Ice at 0 degrees Celsius is more effective in cooling a substance than water at 0 degrees Celsius. So for melting each kilogram of ice, it takes latent heat of this much joules from the substance and hence cools the substance more effectively. Okay, at the same temperature, but the heat is required. Okay, this remember this one. We are melting the solid into liquid, but it takes this much amount of latent heat to every particle of that ice to convert down into liquid. Remember that, students. So now we have completed latent heat of fusion and vaporization is also completed. In the next class, we will complete this chapter. There is only cooling effect of evaporation is left. Okay, students. And from the next class, try to join like more and more students should join the class students. Otherwise, the chapter get over and you will not able to understand the chapter. Okay, students, we will meet in the next class. You can leave the session. Thank you.